Right now, as you settle in for the evening, somewhere in one of the hottest, driest places on Earth, massive rocks are moving across the desert floor, not rolling, not tumbling, but sliding, leaving long trails carved into the earth behind them, like signatures of their journey. Some of these rocks weigh as much as a person, some have traveled hundreds of meters, and for over 60 years, no human had ever seen them move. This isn't a ghost story or an ancient legend. This is Racetrack Playa in Death Valley, California, where stones weighing up to 300 kilograms have been mysteriously migrating across a perfectly flat lake bed, leaving trails that can persist for years. Scientists called them sailing stones, sliding stones, moving rocks, but for decades, nobody could explain what force could possibly move boulders across the desert floor without any sign of human or animal intervention. Perhaps you're thinking this must be simple: wind, earthquakes, something obvious. But here's what makes it truly mysterious. The rocks move in different directions, sometimes turning at sharp angles, sometimes moving uphill slightly, and most bizarrely, rocks sitting right next to each other will sometimes move in completely opposite directions, while others don't move at all. For over half a century, this phenomenon captivated scientists, inspired wild theories, and drew curious visitors from around the world to one of the most inhospitable places on the planet. It became one of geology's most enduring mysteries, a puzzle that seemed to mock our understanding of basic physics. Tonight, we're going to journey to this extraordinary place where nature performs one of its most bewildering magic tricks. We'll explore the theories that failed, meet the scientists who finally cracked the case, and discover how the solution turned out to be both more mundane and more remarkable than anyone imagined. Because sometimes, the most mysterious phenomena have explanations that are hiding in plain sight. We just need the patience to wait for nature to reveal its secrets. So settle back, let your mind wander to a vast, flat expanse of cracked earth under a burning sun, where stones crawl across the ground when no one is watching, and prepare to unravel one of Death Valley's greatest mysteries. Death Valley is a land of extremes. It holds the record for the highest reliably recorded air temperature on Earth, 54.4 degrees Celsius, 129.9 degrees Fahrenheit. It's the lowest point in North America, at 282 feet below sea level. It receives less than 2 inches of rain per year. And within this harsh landscape lies Racetrack Playa, a dried lakebed that looks like something from another planet. The word playa comes from Spanish, meaning beach, but this beach has no ocean. It's a perfectly flat expanse of dried mud, roughly 4.5 kilometers long and 2 kilometers wide, sitting at 1,130 meters above sea level. The surface is composed of hexagonal mud crack patterns that form as the rare rainfall evaporates, leaving behind a natural mosaic that stretches to the horizon. The playa is surprisingly level. The north end is only 4 centimeters higher than the south end across its entire 4.5 kilometer length. This near-perfect flatness is crucial to our mystery. There's no slope that could explain rocks sliding downhill. The surface is so flat that when it does rain, the water forms a shallow lake only a few centimeters deep that covers the entire basin. Surrounding this natural stage are mountains that rise dramatically from the valley floor, the Cottonwood Mountains to the east and the Last Chance Range to the west. These peaks funnel winds down onto the playa, creating a natural wind tunnel that will prove important to our story. But the stars of this show are the rocks themselves. They're not from the playa. They've fallen from the surrounding mountains, tumbling down to rest on the flat surface. They range from small pebbles to massive boulders. The most famous ones have names: Karen, the 700-pound dolomite block; Nancy, Marianne. Visitors have been naming them for decades, anthropomorphizing these silent travelers. The first documented observation of the moving rocks came from prospectors in the early 1900s. These men, searching for gold and borax in the unforgiving desert, stumbled upon something that made them question their sanity. Rocks that had apparently moved across the desert floor, leaving clear trails behind them. But it wasn't until 1948 that the phenomenon received scientific attention. Geologists Jim McAllister and Alan Agnew were mapping the area when they noticed the trails. They published a short article about the sliding stones, sparking curiosity in the geological community. The trails themselves are fascinating. They typically range from tens to hundreds of meters long, though some extend even further. They can be straight, curved, or angular, sometimes making sharp 90-degree turns. The trails are usually 8 to 30 centimeters wide, corresponding to the width of the rock that made them, and they're pressed into the playa surface rather than scraped, suggesting the rocks slide rather than roll. What made the mystery even more intriguing was the variety of trail patterns. Some rocks moved in perfectly straight lines. Others created graceful arcs. Some trails showed rocks moving in parallel, maintaining the same distance apart for hundreds of meters. Others showed rocks starting from the same point and diverging in completely different directions. As news of the sailing stones spread through the scientific community, theories proliferated like desert wildflowers after rain. The wind theory. This was the most obvious explanation. Death Valley experiences powerful winds, with gusts recorded up to 90 miles per hour. Surely wind could push rocks across a flat surface, but calculations showed that even hurricane-force winds couldn't move the largest boulders, and wind couldn't explain why rocks right next to each other moved in different directions, or why some rocks moved while others remained stationary. The ice sheet theory. Some scientists proposed that the playa occasionally froze, creating ice sheets that could carry rocks as they were blown by wind. But Death Valley rarely gets cold enough for substantial ice formation, and this didn't explain the individual trails. Wouldn't all rocks frozen in the same ice sheet move together? The wet mud theory. Perhaps when the playa got wet, it became slippery enough for rocks to slide in moderate winds. This seemed promising, but experiments showed that wet mud actually increased friction. Rocks were harder to move on wet mud than dry. The magnetic field theory. Some suggested Death Valley's geology created unusual magnetic fields that could move rocks containing iron, but many moving rocks were limestone or dolomite, with no magnetic properties. The dust devil theory. Maybe small tornadoes could lift and move rocks, but dust devils would leave disturbed ground around the trails which wasn't observed. More exotic theories emerged from the public. Alien interventions, unknown energy fields, pranksters with elaborate hoaxes. One visitor even suggested the rocks were alive, geological organisms that could somehow locomote. The mystery was becoming a scientific embarrassment. How could we not explain simple rocks moving across flat ground? In 1972, Robert Sharp from Caltech and Dwight Carey from UCLA began the first systematic scientific study of the sliding stones. They selected 30 rocks, gave them names like a geological kindergarten class, and marked their positions with stakes. Then they waited, and waited, and waited. This is one of the challenges of studying the sailing stones. They don't move on schedule. You can't show up and watch them perform. They move when conditions are exactly right, which might be once a year, or once a decade. Sharp and Carey monitored their rocks for 7 years. During that time, 28 of their 30 rocks moved. Some moved multiple times. Nancy, a small 2.5-pound rock, traveled the furthest, over 260 meters. Karen, despite weighing 700 pounds, moved 65 meters in one winter. But frustratingly, despite numerous visits to the playa, they never saw the rocks actually moving. They did make important observations. Most movement happened in winter. Rocks with rough bottoms moved as easily as smooth ones. The trails showed no signs of rolling. The rocks were definitely sliding, and mysteriously, rocks sometimes moved uphill slightly, defying simple wind or water explanations. Their most intriguing discovery was that rocks often moved in parallel. Two rocks would travel side by side, maintaining the same distance apart, suggesting they were carried by the same force. But then, one would stop while the other continued, or they'd suddenly diverge at sharp angles. It was maddening. In 1996, Paula Messina, a geologist from San Jose State University, brought GPS technology to the mystery. She mapped every rock trail on the playa with centimeter precision, creating the first comprehensive database of rock movements. Her analysis revealed patterns. Most trails headed northeast or southwest, corresponding to the prevailing wind directions. But the trails weren't random. They showed a clear relationship to the topography of the surrounding mountains, which funneled winds onto the playa in specific patterns. Messina also discovered that the rocks weren't moving as often as people thought. Some trails that looked fresh were actually decades old. The desert environment preserved them like fossil footprints. A rock might move once in a human lifetime and leave a trail that persisted for generations. She calculated that wind speeds of 150 miles per hour would be needed to move the largest rocks, speeds never recorded in Death Valley. Her work eliminated pure wind as the sole explanation but pointed toward wind being part of a more complex mechanism. As the millennium turned, the sailing stones had become Death Valley's most famous mystery. Documentary crews arrived regularly. Tourism increased. Theories grew wilder. The Park Service had to increase protection as some visitors began stealing rocks or creating fake trails. In 2007, NASA got involved. They were interested because understanding how rocks move on Earth could help interpret similar features on Mars. Trails resembling those at Racetrack Playa had been photographed by Mars rovers. If we couldn't explain Earth's sailing stones, how could we understand Martian geology? Ralph Lorenz, a NASA scientist, had an insight while working on a different project. He was studying how Arctic ice rafts could carry boulders, and he wondered if something similar might happen at Racetrack Playa. Not massive ice sheets, but individual ice collars around rocks. He did a kitchen experiment. He froze a rock in a Tupperware container, creating a rock with an ice collar, then floated it in a tray of water with sand at the bottom. A gentle blow across the water moved the ice-encased rock easily, and it carved a trail in the sand. Could this be the answer? The mystery might have persisted for more decades if not for two cousins with scientific backgrounds and a lot of patience. Richard Norris, a paleobiologist from Scripps Institution of Oceanography, and James Norris, an engineer, decided to solve the mystery once and for all with 21st century technology. In 2011, they got permits to install a high-tech weather station at Racetrack Playa. But more cleverly, they brought their own rocks, fitted with GPS trackers that recorded position every second. If the native rocks wouldn't cooperate with being observed, they'd bring rocks that couldn't hide their movements. They placed 15 GPS-equipped rocks on the playa in winter 2011. Each unit was carefully designed to withstand extreme temperatures, potential submersion, and they hoped whatever force was moving the rocks. The GPS units could detect movement as small as 5 centimeters. Then, like their predecessors, they waited. The first winter passed, no movement. The second winter began the same way. They started to wonder if they'd fail like everyone before them. But then, in December 2013, everything changed. On December 4th, 2013, a rare weather event occurred. Rain fell on Racetrack Playa, not much, just enough to cover the basin with a few centimeters of water. This happens occasionally, perhaps once or twice a year, creating a temporary shallow lake. That night, temperatures dropped below freezing. The shallow water began to freeze, but not into a thick sheet. Instead, it formed window pane ice, sheets only 3–6 millimeters thick, like giant floating windows of ice across the playa. On the morning of December 20th, Richard and James Norris arrived at the playa and witnessed something no scientist had seen before. As the sun rose and warmed the ice, it began to break up into large panels, some 10 meters across or more. The wind picked up to about 10 miles per hour, not particularly strong by Death Valley standards. But then magic happened. The floating ice panels, pushed by the gentle wind, began to move across the shallow water, and as they moved, they pushed against the rocks. The rocks, sitting on mud softened by water, and now being pushed by ice panels with the entire force of the wind behind them, began to slide. It was beautiful and mundane simultaneously. No hurricane winds, no mysterious forces, just thin ice, light wind, and physics. The rocks moved slowly, only about 5 meters per minute, but they moved. Some were pushed by single ice panels, others by multiple panels that crashed into them in sequence. The GPS data was extraordinary. Over the next few months, their instrumented rocks moved multiple times. One rock moved 224 meters total. The data showed rocks could move at speeds up to 5 meters per minute, much faster than anyone had guessed from looking at the trails. The complete mechanism, now understood, is elegantly simple, yet requires a perfect combination of rare conditions. Step 1. Rain. The playa must fill with water, but just the right amount. Too little, and there's no water to freeze. Too much, and the ice would be too thick to move easily. The ideal depth is 3 meters 7 centimeters. Step 2. Freezing. The temperature must drop below freezing at night, but not too far below. The ice needs to be thin enough to float and break easily. Window pane ice of 3 to 6 mm is perfect. Step 3. Sun and wind. The next day must be sunny enough to warm the ice and create thermal fracturing, but windy enough to move the panels. The wind doesn't need to be strong. 10 to 15 miles per hour is sufficient. Step 4. Ice rafting. The broken ice panels, floating on the remaining water, are pushed by wind. When they encounter rocks, they push them along. Multiple panels can hit the same rock, changing its direction. Step 5. Trail formation. As rocks are pushed through the soft, wet mud, they leave trails. The water and ice eventually disappear, but the trails remain, slowly hardening in the desert sundot. This explanation resolved all the mysteries. Rocks could move in different directions because they were pushed by different ice panels. Neighboring rocks might not move if ice panels missed them. Rocks could move uphill slightly if pushed by ice panels piling up behind them. The reason it took 60 years to solve the phenomenon is incredibly rare to witness. It requires the exact combination of rain, freezing, sun, and wind, conditions that might align only a few days per decade. And it happens in winter in one of the most remote places in North America. Even when it occurs, the window to observe it is brief, usually just a few hours in the morning, before the ice completely melts. The Norris cousins' discovery was published in 2014, but some scientists wanted additional confirmation. In 2016, another team revisited the playa with even more sophisticated equipment, including time-lapse cameras and weather sensors. They confirmed the ice rafting mechanism and added new details. The ice panels could be huge, up to 100 meters across, essentially ice sails catching the wind. Sound of the ice breaking and moving was haunting, creaking, groaning, tinkling as pieces collided. One researcher described it as like being inside a giant's jewelry box. They also discovered that not all rocks move the same way. Smaller rocks might be completely encased in ice and float. Larger rocks are pushed by ice panels hitting them. The very largest rocks might only move when multiple ice panels pile up against them, concentrating force. The trails preserve a record of these different movement styles. Straight trails suggest consistent pushing by large ice panels. Curved trails might indicate the rock was being rotated by uneven ice pressure. Sharp turns mark where one ice panel stopped and another from a different direction took over. Solving the sailing stone's mystery might seem like satisfying curiosity about a geological oddity, but it has broader implications. Planetary geology. Similar trails have been observed on Mars and possibly other celestial bodies. Understanding Earth's sailing stones helps interpret these features. Mars has dust storms, temperature variations, and possibly subsurface ice. Could similar mechanisms operate there? Climate records. The trails are archives of past weather events. By studying old trails, scientists can reconstruct historical climate conditions in Death Valley. How often did conditions allow rock movement in the past? Is it changing with climate change? Erosion and sediment transport. The mechanism demonstrates how significant sediment transport can occur in unexpected ways. In Arctic and Antarctic environments, similar ice rafting might move substantial amounts of material. Patience in science. The sailing stones remind us that some natural phenomena operate on timescales that challenge human observation. How many other mysteries remain unsolved simply because we haven't waited long enough or been in the right place at the right time? Racetrack Playa isn't the only place with sailing stones, though it's the most famous. Similar phenomena have been documented at Bonnie Claire Playa, Nevada. Rocks move here too, though less dramatically. The mechanism appears similar. Ice rafting in winter conditions. Laguna Altilo Chica, Spain. A high-altitude lake where rocks slide across frozen surfaces, leaving trails on the lakebed. Various Arctic locations. Ice-rafted boulders are common in polar regions, though they usually move into water rather than across dry land. Each location adds details to our understanding. The Spanish site shows that altitude can substitute for latitude in creating the right conditions. Arctic examples demonstrate the power of ice to move enormous boulders, some weighing many tons. The sailing stone story is as much about human nature as natural phenomena. For 60 years, people preferred mystery to mundane explanation. Even after the solution was found, some visitors expressed disappointment. Ice-rafted rocks seem less magical than stones moving by mysterious forces. This reveals something about our relationship with nature. We want it to be mysterious, to hold secrets, to surprise us. When a mystery is solved, we feel a loss alongside the gain of knowledge. The sailing stones were more valuable as a mystery than as a solved problem. But there's magic in the real explanation too. The precise combination of conditions required, the rarity of occurrence, the elegant simplicity of the mechanism. These are wonders in themselves. Nature doesn't need supernatural forces to be extraordinary. The human stories are compelling too. Generations of scientists dedicating careers to solving this puzzle. The Norris cousins, using vacation time and personal funds to crack the case. Volunteers camping in freezing Death Valley winters, hoping to witness movement. The mystery created a community, united by curiosity. I first visited Racetrack Playa in 2010, before the mystery was solved. The journey itself was an adventure. 27 miles of rough dirt road from the nearest paved highway, requiring high-clearance vehicles and careful driving. The isolation was absolute. No cell service, no facilities, no water, just vast silence and space. Seeing the trails in person was more impressive than any photograph conveyed. Some stretched impossibly far across the playa, disappearing into heat shimmer. The rocks themselves seemed deliberately placed, like art installations. Karen, the famous 700-pound boulder, sat at the end of a trail that turned several times, as if she'd been dancing. I spent hours walking among the stones, trying to imagine what force could move them. The playa was so flat, so dry, so still. Even with strong wind that day, I couldn't budge the smallest rocks. The mystery felt absolute, unsolvable. What struck me most was the time-scale mismatch. These rocks might move once in a decade, leave a trail that lasts a century. Human observation seemed futile against such patient phenomena. Were mayflies trying to understand mountains? I returned in 2015, after the mechanism was understood. The mystery was solved, but the wonder remained. If anything, knowing the explanation enhanced the experience. I could imagine the shallow lake, the forming ice, the morning when everything aligned perfectly. I realized that understanding doesn't diminish wonder, it transforms it. Instead of wondering how, I wondered at the precise choreography required. The odds of witnessing movement seemed even more precious, knowing how rare the conditions were. The trails took on new meaning. Each was a record of a specific morning, a particular configuration of ice and wind. Some trails might record events from decades ago, others from last winter. They were signatures of moments when physics aligned perfectly. The lesson of patience, The sailing stones taught me about patience and understanding nature. We live in an age of instant information, immediate gratification, constant stimulation, but some phenomena refuse to conform to human timescales. How many mysteries remain unsolved, not because they're unsolvable, but because we haven't watched long enough? How many rare events have we never witnessed, because they happen once per century? The sailing stones humble our assumption that nature performs on our schedule. They also teach about persistence. Scientists studied these rocks for 60 years without seeing them move. Each generation built on previous work, adding data, eliminating false theories, refining hypotheses. The solution came not from brilliant insight, but from patient observation and technological advancement. The solved mystery hasn't diminished tourist interest. If anything, it's increased. People want to see the famous rocks, walk among the trails. Imagine the ice rafting events. The National Park Service has had to balance access with protection. Some problems have emerged. Visitors have stolen rocks, thinking them magical. Others have created fake trails, contaminating the scientific record. Some have driven vehicles onto the playa, leaving tire tracks that last decades. The park now emphasizes education. Strangers explain the mechanism, the rarity, the scientific importance. They've installed interpretive signs at the parking area. The message: the rocks are remarkable, not despite the mundane explanation, but because of it. The sailing stones have inspired numerous artistic works. Photography. The trails create natural compositions, leading lines across cracked earth, shadows at sunset, rocks as punctuation marks in vast emptiness. Photographers wait for perfect light, using the trails as graphic elements. Literature. Several novels feature the sailing stones as plot elements or metaphors. They represent patience, mystery, the unknowable. Poets use them to explore themes of movement and stillness, permanence and change. Film. Documentaries have chronicled both the mystery and solution. The visual drama of Death Valley provides cinematic backdrop. Time-lapse footage of ice movement has become iconic. Music. Composers have created pieces inspired by the sailing stones, using sliding tones and patient development to echo the rock's movement. One piece uses GPS data from moving rocks to generate musical phrases. The sailing stones have become a textbook example of several scientific principles. Patient observation. Science education uses the story to teach about long-term studies and the importance of persistence. Occam's razor. The simple explanation: ice rafting proved correct over exotic theories. Magnetic fields, aliens, interdisciplinary approach. Solving the mystery required geology, meteorology, physics and technology. Citizen science. Amateur observers contributed valuable data over decades, showing how non-professionals can advance science. The story appears in geology textbooks, science museums and educational programs. It's become a parable about the scientific method. Hypothesis, observation, revision, solution. As Earth's climate changes, the conditions that create sailing stones might become rarer or shift location. Death Valley is getting hotter and potentially drier. So will future generations see moving rocks? Some scientists use the sailing stones as climate indicators. The frequency of movement events might correlate with broader climate patterns. Historical trail analysis could reveal past climate variation. Conversely, new locations might develop sailing stone conditions. As temperature and precipitation patterns shift, other playas might begin experiencing the precise combination needed for ice rafting. The Mars rovers have photographed trails that look remarkably similar to those at Racetrack Playa, but Mars has no liquid water on its surface now. So what's moving Martian rocks? Possible mechanisms include dry ice, frozen CO2, sublimating, and providing thrust. Dust devils strong enough to move rocks in Mars's low gravity. Ancient trails from when Mars had liquid water. Seasonal. Frost creating slip conditions. Understanding Earth's sailing stones helps eliminate certain explanations and suggests others. The racetrack playa mechanism might not work on Mars, but the methodology for solving such mysteries applies everywhere. Future Mars missions might place GPS-equipped rocks like the Norris cousins did, waiting patiently for Martian rocks to reveal their secrets. The sailing stones have become a template for investigating mysterious geological phenomena throughout the solar system. The sailing stones raise philosophical questions about knowledge and mystery, the value of not knowing for 60 years. The mystery enriched human culture. It inspired visits, sparked imagination, created community. Was something lost when it was solved? The nature of explanation. The ice rafting mechanism explains how but not why, in a deeper sense. Why does nature create such phenomena? What purpose does it serve? Scientific explanation doesn't exhaust meaning. The democracy of mystery. The sailing stones were equally mysterious to Nobel laureates and children. Mystery levels hierarchies, creating shared wonder. The persistence of wonder. Even solved, the phenomenon remains wondrous. Understanding the mechanism doesn't diminish the improbability, the beauty, the surprise that such things happen. Despite the basic mechanism being solved, research continues. Trail preservation. How long do trails last? What conditions preserve or erode them? This helps date old trails and understand historical movement patterns. Rock properties. Do certain rock types move more easily? How does shape affect movement? Scientists are creating a database of rock characteristics and movement histories. Microclimate analysis. The playa has subtle variations in temperature, wind, and moisture. How do these affect movement patterns? High-resolution weather monitoring continues. Ice formation. The exact physics of windowpane ice formation needs more study. What determines thickness? How large can panels grow? Laboratory experiments complement field observations. Technological advances. New technologies are revealing additional details. Drone surveys. Aerial photography maps all trails simultaneously, revealing patterns invisible from ground level. LiDAR scanning. Laser scanning creates millimeter-precise 3D models of trails, preserving them digitally before erosion. Satellite monitoring. Regular satellite images might catch movement events, expanding observation beyond ground visits. AI analysis. Machine learning algorithms analyze trail patterns, potentially revealing subtle mechanisms or historical changes. Seismic sensors. Detecting micro-vibrations might reveal rock movement in real time, even from remote locations. As our journey through the mystery of the sailing stones comes to an end, we return to that vast playa under the desert sun. The rocks sit silently now, perhaps not to move again for years. Their trails slowly fade as wind and rare rain erode them. New rocks fall from the mountains, beginning their own patient wait for the perfect conditions. The sailing stones have given us many gifts. They've taught us about patience, that some natural phenomena refuse to perform on human schedules. They've shown us the power of persistence, that 60 years of observation can finally capture a moment of movement. They've demonstrated that simple explanations can underlie seemingly impossible phenomena. But perhaps their greatest gift is reminding us that Earth still holds mysteries. Even well-studied places can surprise us. Even in the age of satellites and computers, some secrets require being in the right place at the right time with the right technology and the right amount of luck. The sailing stones serve as a powerful metaphor for many things. Scientific progress. Like the rocks, knowledge moves slowly, leaving trails of understanding. Sometimes it changes direction unexpectedly. Sometimes it stops for long periods before conditions align for another advance. Human life. We too leave trails, impacts on others, changes to our environment, marks of our passage. Like the rocks, we're moved by forces we don't always perceive or understand. Patience. In our accelerated age, the sailing stones remind us that some things cannot be rushed. Some mysteries yield only to patient observation over decades. Simplicity. The most mystifying phenomena often have simple explanations. Not everything mysterious requires exotic solutions. The story of the sailing stones isn't over. Rocks continue to wait for perfect conditions. Scientists continue to monitor and study. Visitors continue to make the difficult journey to witness the trails. The mystery is solved, but the wonder persists. Climate change might alter the conditions that allow rocks to sail. Future generations might see the last of the moving rocks, or they might witness new patterns we haven't imagined. The trails we see today might be preserved for centuries or erased by next year's rain. Each trail is temporary, but the phenomenon persists. Each rock moves alone, but they're part of a larger pattern. Each mystery solved reveals new questions. This is the nature of scientific discovery, answers that lead to deeper questions, solutions that reveal greater mysteries. Their quote, "It's a deep peace in finally understanding the sailing stones." Not the peace of completed knowledge, but the peace of patient revelation. For 60 years, humans wondered. Then, in a few morning hours in December 2013, nature revealed its secret. The answer was worth the wait. This peace comes from knowing that the world still operates by comprehensible rules, even when those rules create incomprehensible seeming phenomena. It comes from seeing human persistence rewarded. It comes from discovering that the mundane explanation, thin ice and light wind, creates genuinely magical results. As you drift toward sleep tonight, perhaps you'll dream of Death Valley's sailing stones. In your dreams you might see them as they truly move, slowly, majestically, pushed by translucent sheets of ice across a shallow lake under the winter sun. You might hear the crack and tinkle of breaking ice, feel the cold wind, see the rocks beginning their patient journey across the playa. Or perhaps you'll dream of being one of those rocks, waiting through years of stillness for the perfect moment, then sliding across the desert floor, leaving your mark on the earth, your trail telling the story of your journey to anyone patient enough to read it. The sailing stones of Death Valley have completed their journey from mystery to understanding, but they continue their physical journeys across Racetrack Playa. Each winter brings the possibility of movement. Each trail tells a story of perfect conditions aligning. We've followed their trails through decades of scientific investigation, through failed theories and patient observation, through technological advancement and lucky timing. We've seen how the most mysterious phenomena can have simple explanations, how patience and persistence solve puzzles that seem impossible. The rocks will continue to sail long after we're gone. Future generations will see new trails, witness movements we can only imagine. The phenomenon that took 60 years to explain will continue for millennia. Each movement event a small miracle of physics, a dance of ice and wind and stone. Thank you, sailing stones, for your patient teaching. Thank you for remaining mysterious just long enough to teach us about mystery itself. Thank you for moving when no one was watching for so long and finally allowing yourself to be seen. Thank you for showing us that the world still holds wonders, that patience is rewarded, that simple explanations can be beautiful. Your trails cross Racetrack Playa like sentences written in an ancient language, now finally translated, but even understood, they remain poetry, the poetry of physics. The verse of patient time, the story of stones that sail across the desert when conditions are exactly, perfectly, rarely right. Sleep well, and may your dreams be filled with sailing stones, moving mysteries and the patient revelation of wonders. The rocks continue their journey, and so do we, leaving our own trails across the surface of time, moved by forces we're only beginning to understand. Every failed theory about the sailing stones contributed to the eventual solution. This is how science progresses, not through immediate breakthrough, but through systematic elimination of impossibilities. The wind-only theory failed, but it established wind as a necessary component. Scientists calculated exact wind speeds needed for different rock weights. When Hurricane Katrina's winds were compared to Death Valley's maximum recorded winds, it became clear that wind alone couldn't explain the largest moving rocks. But this didn't eliminate wind. It just proved wind needed help. The magnetic field theory seemed absurd in retrospect, but it led to important discoveries. Scientists thoroughly mapped Death Valley's magnetic fields, finding interesting anomalies that, while not moving rocks, helped understand the region's geological history. They discovered that some rocks were slightly magnetic, containing trace amounts of magnetite, but nowhere near enough to explain movement. The ice sheet theory was closest to correct but wrong in scale. Early scientists imagined massive ice sheets like those in polar regions. They calculated that ice would need to be meters thick to float and carry heavy rocks. This seemed impossible in Death Valley. But the error was assuming ice needed to carry rocks rather than push them. The solution required thinking smaller, millimeter-thin ice, not meter-thick sheets. Even the alien theory, while never taken seriously by scientists, led to better documentation. To disprove human or otherworldly intervention, researchers installed hidden cameras, motion sensors, and other monitoring equipment. This technology, intended to catch hoaxers, eventually captured the real phenomenon. The sailing stones revealed interesting aspects of human psychology. People often preferred exotic explanations to mundane ones. When the ice rafting solution was published, some expressed disappointment. Aliens or mysterious energy fields seemed more satisfying than thin ice and light wind. This preference for mystery over explanation is deeply human. We're drawn to the unexplained, the supernatural, the impossible. It makes the world seem bigger, more magical, more interesting. When mysteries are solved, we feel a loss alongside the gain of knowledge. Psychologists studying reactions to the sailing stone solution found that people who had visited Racetrack Playa before the explanation felt more disappointment than those who learned about both mystery and solution simultaneously. Investment in mystery makes its resolution bittersweet. But there's a different kind of wonder in understanding, knowing that precise conditions must align, rain, then freezing, then sun and wind, makes each movement event seem more precious. The rocks aren't moving mysteriously, they're moving miraculously through a conspiracy of rare circumstances. The technology used to study sailing stones mirrors the evolution of scientific instruments over 60 years, 1940s to 1950s. Basic surveying equipment, tape measures, stakes, notebooks. Scientists could document positions but not movements. 1960s to 1970s. Better cameras, including time-lapse capability. Chemical analysis of rocks and soil. Wind speed meters permanently installed. 1980s to 1990s. Satellite imagery, GPS technology, computer modeling. Scientists could track changes between visits with precision. 2000s, digital cameras, internet connectivity for remote monitoring, sophisticated weather stations recording multiple variables. 2010s, miniaturized GPS units attached to rocks, high-definition video, real-time data transmission, smartphone apps for citizen science. Each technological advance brought scientists closer to the solution. But ironically, the breakthrough came not from high-tech observation, but from being in the right place with relatively simple tools, cameras and GPS units, that any consumer could buy. The sailing stones aren't unique to Death Valley. Similar phenomena occur worldwide, each with local variations. Laguna de Lillo, Spain, at 1,400 meters elevation, this frozen lake shows rocks moving across ice. Unlike Death Valley, the movement happens on permanent ice in winter. Rocks leave scratches rather than pressed trails. Local shepherds have known about it for centuries but never reported it to scientists. Ramsko Lake, Bosnia. Rocks move here during spring ice breakup. The mechanism is different. Ice chunks carry rocks as they're blown across the lake, but the visual effect is similar. Rocks found far from where they started with clear travel evidence. Qinghai Lake, China. On the Tibetan Plateau, rocks slide across frozen surfaces at 3,200 meters elevation. The high altitude creates Death Valley-like conditions, extreme temperature variations, thin air, strong winds. Chinese scientists studied these for decades before learning about Racetrack Playa. Arctic Ocean seafloor, Submarine cameras have recorded trails on the ocean floor made by rocks pushed by moving ice above. These trails can be kilometers long, carved into seafloor sediment. They're preserved for millennia in the cold, dark depths. Each location adds to our understanding. Spanish rocks show that elevation can substitute for desert conditions. Bosnian rocks demonstrate ice carrying versus ice pushing. Chinese rocks reveal that the phenomenon scales with altitude. Arctic rocks prove the mechanism works underwater. Different cultures have varied explanations for moving rocks. Native American traditions, the Timbisha Shoshone, indigenous to Death Valley, have oral traditions about the moving rocks. They speak of rocks having spirits that travel to gather for ceremonies. The trails are paths between sacred sites. This interpretation sees agency and purpose rather than random physical forces. Spanish folklore. In regions with moving rocks, local folklore often attributes movement to witches or saints. Some stories tell of rocks moving to mark boundaries between good and evil. Others describe rocks traveling to holy sites on religious holidays. Chinese philosophy. Moving rocks in Tibet are sometimes interpreted through Taoist philosophy. Objects in perfect harmony with natural forces, moving without effort when conditions align. The rocks demonstrate Wu Wei, effortless action. Modern mythology. New Age communities have adopted the sailing stones as symbols of possibility and transformation. They represent the idea that seemingly immobile situations can change when conditions are right. Some meditation centers use sailing stone imagery for teachings about patience and sudden breakthrough. These cultural interpretations aren't scientifically correct, but they reveal human needs that pure science doesn't address: the need for meaning, purpose, and connection to nature's mysteries. Understanding the sailing stones requires understanding Death Valley's remarkable geology. The valley formed through block faulting, the Earth's crust literally pulling apart. As the crust stretched, some blocks dropped, forming valleys while others rose, creating mountains. This process began about 14 million years ago and continues today. Death Valley is still sinking while surrounding mountains rise. GPS measurements show the valley floor dropping about 2 millimeters per year, while mountains rise at similar rates. In geological time, this is breakneck speed. The rocks that sail across racetrack playa have their own stories. Most are dolomite from the surrounding mountains, formed 600 million years ago, when this area was a shallow sea. These ancient seafloor sediments were compressed into stone, lifted into mountains, then broken off to slide across a desert that was once their ocean floor. Some sailing stones are volcanic, from eruptions 10-12 million years ago, when the stretching crust allowed magma to surface. These darker rocks often move differently than sedimentary rocks. Their rougher surfaces create more friction, requiring stronger forces to move. The playa itself is young, geologically speaking. It formed perhaps 10,000 years ago, as climate changed after the last ice age. What was once a permanent lake became seasonal, then dried completely, except for rare rain events. The flat surface, essential for sailing stones, took millennia to perfect. Death Valley's extremes create the conditions necessary for sailing stones. Temperature range. Summer temperatures reach 54 degrees Celsius, 130 degrees Fahrenheit, but winter nights can drop below freezing. This 60 degrees Celsius range in a single year creates the thermal conditions for ice formation, despite the desert setting. Rainfall. Average annual precipitation is less than 50 mm, but it occasionally comes in single events. These rare deluges create the temporary lakes necessary for ice formation. Wind patterns. Mountains surrounding racetrack playa create a natural wind tunnel. Prevailing winds from the southwest are funneled and accelerated. Winter storms can generate sustained winds of 50+ mph with higher gusts. Elevation. At 1,130 meters, racetrack playa is high enough for freezing temperatures but low enough for extreme summer heat. This elevation sweet spot is crucial for the sailing stone mechanism. Isolation. The remoteness means minimal human interference. The 27-mile rough road deters casual visitors. This isolation preserved the mystery but also made research difficult. Despite harsh conditions, life persists at Racetrack Playa. Desert plants, scattered creosote bushes, and desert holly survive on minimal water. Their presence shows where slightly more moisture accumulates. Some are centuries old. Having witnessed countless rock movements, microorganisms, the playa's mud contains extremophile bacteria that survive desiccation, freezing, and intense UV radiation. These organisms become active during brief wet periods, contributing to the mud's unique properties. Visiting animals. Kit foxes, bighorn sheep, and ravens visit the playa. Their tracks sometimes cross rock trails, helping date movements. A raven feather found under a rock proved the rock had moved within the feather's decomposition timeframe. Temporary ecosystems. When rain creates shallow lakes, a temporary ecosystem explodes into existence. Dormant brine shrimp eggs hatch, algae blooms, and migrating birds arrive to feed. This ecosystem might last days or weeks before vanishing. Life here demonstrates the same patience as the sailing stones, waiting for rare perfect conditions, then acting quickly when opportunity arrives. The sailing stones created a unique breed of dedicated researchers. Robert Sharp spent 30 years studying the rocks, making over 100 trips to Racetrack Playa. He documented every rock position change, weather event, and trail formation. His detailed notes, now archived at Caltech, remain valuable for understanding historical movements. Sharp never saw the rocks move, but remained convinced he would if he just waited long enough. Paula Messina devoted her doctoral dissertation to the sailing stones. She spent months camping at the playa, enduring extreme temperatures and isolation. Her GPS mapping revolutionized understanding of movement patterns. She describes becoming so familiar with individual rocks that she could identify them from their trails alone. Richard and James Norris invested personal funds and years of effort. They designed custom equipment, obtained permits, and made dozens of trips. When they finally witnessed movement, Richard described it as the most exciting moment of my scientific career, despite his distinguished paleontology background. Dwight Carey continued studying the rocks into his 90s, making his last field trip at age 91. He joked that the rocks would outlive him, which they did. He passed away still wondering about their movement mechanism. These scientists demonstrate unusual dedication. Most research offers regular data, publishable results, career advancement. The sailing stones offered only patience and possibility. Citizens, scientists made crucial contributions. Park rangers, generations of Death Valley rangers, documented rock positions during patrols. Their observations, spanning decades, provided continuity between formal studies. Photographers, artists seeking dramatic images, often noticed position changes before scientists visited. Their dated photographs became scientific documents. Tourists, careful visitors who respected the rocks while documenting positions, helped expand observation. Some created detailed sketches that proved valuable for tracking movements. Local residents, people living near Death Valley, reported weather conditions, unusual events, and changes. Their local knowledge helped scientists understand patterns. This democratic participation shows how mystery draws people together. The sailing stones became a shared puzzle that anyone could help solve. Not all human interaction was positive. Theft. Some visitors stole rocks, believing them magical or valuable. This disturbed scientific study and damaged the natural phenomenon. Stolen rocks lost their context and scientific value. Fake trails. Some people created false trails by dragging rocks, contaminating the scientific record. Researchers had to develop methods to identify authentic versus human-made trails. Vandalism. Vehicles driven onto the playa left permanent tracks. Graffiti appeared on some rocks, Beer cans and trash accumulated at popular viewing spots. Protection efforts. In response, the National Park Service increased patrols and education. Volunteers organized cleanup expeditions. Scientists developed protocols for minimizing research impact. The human impact story shows how fame threatens the phenomena we celebrate. The sailing stones survived millions of years of natural forces, but faced their greatest threat from human curiosity. The actual physics of ice-rafted rock movement is more complex than simple pushing. Ice formation dynamics. The 3 to 6 mm window pane ice forms through a specific process. Water must be shallow enough to cool quickly, but deep enough to float ice. The ice forms from the top down, trapping a thin water layer beneath. This water acts as a lubricant, allowing ice sheets to slide freely. Force calculations. A 10-meter square ice panel, 5 mm thick, weighs about 460 kilograms. Wind pushing this ice at 10 miles per hour generates roughly 50 newtons of force per square meter. This force, concentrated where ice meets rock, can overcome friction and start movement. Friction coefficients. Wet playa mud has a static friction coefficient of about 0.3 meters 0.4. Once moving, kinetic friction drops to 0.1 meters 0.2. This explains why rocks are hard to start, but easy to keep moving. Ice contact distributes force, preventing rocks from sinking into mud. Momentum transfer. Ice panels don't just push, they transfer momentum. A moving ice sheet hitting a stationary rock creates an elastic collision. The rock accelerates while the ice decelerates. Multiple ice impacts can accelerate rocks to surprising speeds. Directional changes. When ice panels break, rocks can be caught between different sheets moving in different directions. This creates the sharp turns seen in some trails. Computer models show that random ice breaking can produce all observed trail patterns. The playa surface has unique chemical properties, crucial for sailing stones. Clay composition. The mud is primarily composed of extremely fine clay particles weathered from surrounding mountains. These particles are smaller than 2 micrometers, creating a nearly impermeable surface when dry. Salt content. Dissolved minerals from millennia of evaporation create a salt concentration of 2 to 3%. This affects freezing point, ice formation and mud properties. Salt lowers the freezing point, requiring colder temperatures but creating different ice structures. Organic content. Despite the harsh environment, the mud contains organic compounds from algae and bacteria. These create biofilms that affect surface properties. When wet, these films become extremely slippery. pH levels. The playa surface is alkaline, with pH around 8 meters 9. This affects rock-mud interaction and trail preservation. Alkaline conditions help cement trails after formation. Expansion properties. When wet, the clay expands up to 40% in volume. This expansion creates the polygonal crack patterns and affects how rocks sink or float on the surface. Precise weather conditions needed for rock movement are remarkably specific. Precipitation. 5 to 10 mm of rain is optimal. Less doesn't create sufficient water depth. More creates ice too thick to move easily. This amount occurs at racetrack playa perhaps 2 meters 3 times per winter. Temperature profile. Nighttime temperatures must drop to between -1 degree Celsius and -4 degrees Celsius. Colder creates ice too thick. Warmer doesn't create ice at all. Daytime must warm to above freezing but not too quickly. Spring timing. Wind must coincide with ice breaking. Morning winds of 10 to 15 miles per hour are ideal. Afternoon winds usually come too late, after ice has melted. Wind direction must align with playa orientation. Solar radiation. Bright sun is needed to warm ice and create thermal fracturing. Cloudy days don't generate sufficient temperature gradients. The sun angle in winter is perfect for gradual warming. Humidity. Low humidity, typical of Death Valley, allows rapid temperature changes. High humidity would moderate temperatures, preventing the necessary extremes. These conditions align perhaps 1 meters 5 days per decade, explaining the phenomenon's rarity. Global warming might affect the sailing stones in complex ways. Temperature changes, warmer winters, might reduce freezing nights, but could also increase rainfall. The net effect is uncertain. Models suggest movement events might become rarer, but more dramatic. Precipitation patterns. Climate change is altering storm tracks. The atmospheric rivers that bring rain to Death Valley might shift north or intensify. Changed rainfall could dramatically affect rock movement frequency. In wind patterns, rising temperatures change pressure gradients, affecting wind. Stronger temperature contrasts between mountains and valleys might increase wind speeds, compensating for less ice formation. Playa surface changes. Different weather patterns might alter the playa's surface chemistry and structure. More rain could wash away salts, changing friction properties. Less rain could create a harder surface. Long-term cycles. The sailing stones might be sensitive to decades-long climate cycles, like El Niño-La Niña or the Pacific Decadal Oscillation. Historical trail analysis might reveal these connections. Scientists are establishing baseline measurements now to detect future changes. The sailing stones might become climate change indicators, their movement frequency recording shifting conditions. Ancient trails and geological evidence reveal the sailing stone's history. Pleistocene lakes. During ice ages, Death Valley contained large lakes. Sailing stones couldn't exist then. But as lakes dried, conditions became suitable. The phenomenon might be only 10,000 years old. Trail preservation. Some trails appear extremely old based on weathering patterns. These might record climate conditions from centuries or millennia ago. Dating techniques are being developed. Rock distribution. The current distribution of rocks on the playa might record historical movement patterns. Statistical analysis could reveal past climate variations. Sediment cores. Drilling into playa sediments reveals layers recording wet and dry periods. These correlate with probable movement events, creating a timeline. Isotope analysis. Oxygen isotopes in trail minerals can indicate temperature during formation. This might reveal whether past movements occurred under different conditions. This paleoclimate work shows the sailing stones as more than curiosity. They're environmental archives recording Death Valley's climate history. The sailing stones are part of Racetrack Playa's broader ecosystem. Habitat creation. Rock trails create microtopography on the otherwise flat playa. These slight depressions collect water, supporting different organisms than surrounding areas. Seed dispersal. Moving rocks might transport seeds attached to their surfaces. This could explain the distribution of some playa plants. Nutrient distribution. Rocks weather as they move, releasing minerals. Trails might be more fertile than surrounding mud, affecting plant growth patterns. Animal behavior. Some animals use sailing stones as landmarks or shelter. Kit foxes have been observed investigating rocks, possibly hunting prey that shelter beneath them. Microbial communities. Different bacteria colonize rocks versus mud. Moving rocks might spread microbial communities across the playa. These interactions show the sailing stones as active ecosystem participants, not just geological curiosities. The sailing stones have inspired engineering solutions. Low friction transport. The ice rafting mechanism suggests methods for moving heavy objects with minimal energy. Engineers are exploring applications for construction and manufacturing. Self-organizing systems. The way multiple ice panels coordinate to move rocks inspires algorithms for robotic swarms. Distributed systems could achieve complex tasks through simple local interactions. Passive movement systems. The rocks move without power sources, using environmental energy. This inspires designs for autonomous systems that harvest environmental energy. Surface treatment. Understanding how playa mud properties enable movement inspires new lubricants and surface treatments. Bio-inspired surfaces could reduce friction in industrial applications. Weather-triggered mechanisms. Devices that activate only under specific conditions, like the sailing stones, could be useful for environmental monitoring or emergency response. The sailing stones directly influence Mars exploration, rover design. Understanding how rocks move on Earth helps interpret Martian geology. Rover instruments are designed to detect similar phenomena. Landing site selection. Areas with potential moving rocks are scientifically interesting but might be hazardous for landers. The sailing stone mechanism helps assess risks. Climate reconstruction. Martian rock trails might record past climate conditions. Earth's sailing stones provide a template for interpretation. Life detection. If microorganisms affect Earth's sailing stones, similar interactions might occur on Mars. This guides life detection strategies. Future missions. Proposals exist for Mars missions specifically to study moving rocks, using technology tested at racetrack Playa. The sailing stones inspire new materials. Self-cleaning surfaces. The way ice sheets slide off rocks inspires surfaces that shed contamination. Applications include solar panels and windows. Adaptive friction materials. Materials that change friction properties based on conditions like playa mud could improve tires, shoes, and industrial equipment. Phase change lubricants. Substances that transition between states to enable movement, inspired by the ice-water mud system. Smart composite materials. Materials that respond to environmental triggers, moving or changing shape when conditions are right. These applications show how studying natural phenomena leads to practical innovations. The sailing stones exemplify how science actually works versus popular perception. Nonlinear progress. The solution didn't come from steady advancement, but from lucky timing and prepared minds. Decades of no progress, then sudden breakthrough. Collaborative nature. No single hero solved the mystery. Each researcher built on previous work. The solution required generations of accumulated knowledge. Technology dependence. The mystery couldn't be solved until appropriate technology existed. GPS units small enough to attach to rocks were crucial. Serendipity role. The Norris cousins happened to visit during a rare movement event. Without luck, the mystery might have persisted decades longer. Persistence requirement. Most scientists studying sailing stones never saw them move. They contributed anyway, trusting future researchers would build on their work. This reality differs from media portrayals of dramatic breakthroughs by lone geniuses. The sailing stones challenge our temporal perspective. Generational phenomena. Events occurring once per decade exceed individual research careers. Understanding requires institutional memory and cultural continuity. Deep time intersection. Rocks formed hundreds of millions of years ago move on timescales of decades, observed by humans living for years. Multiple temporal scales intersect. Patience paradox. Humans seeking immediate answers must wait for geological patience. The urgency of curiosity meets the patience of nature. Memory and documentation. Without written records, the phenomenon would be mythological. Documentation allows us to transcend individual temporal limitations. Future responsibility. Current researchers document for future scientists who might witness what they cannot. We contribute to understanding we might not live to see completed. These temporal considerations show humans grappling with phenomena beyond our natural scales. The sailing stones raise questions about mystery's value. Instrumental value. Mysteries drive research funding and public interest. Once solved, attention often shifts elsewhere. Mystery has practical utility. Intrinsic value. Some argue mysteries have value independent of solutions. They inspire wonder, humility, and imagination. Solutions might diminish this value. Educational value. Mysteries teach patience, observation, and humility. The process of investigating mysteries might be more valuable than solutions. Cultural value. Shared mysteries create community. The sailing stones brought together scientists, artists, and curious citizens across generations. Existential value. Mysteries remind us the world exceeds our understanding. They preserve enchantment in an increasingly explained world. The sailing stones embody these tensions between knowing and not knowing. Modern technology has transformed sailing stone observation. Webcam networks, solar-powered cameras now monitor racetrack playa continuously. Live streams allow global observation. Movement events can be detected remotely. Smartphone apps. Visitors can contribute observations through dedicated apps. GPS positioning, photos, and descriptions are automatically uploaded to research databases. Drone surveys. Regular drone flights create high-resolution maps. Changes are detected automatically through image comparison algorithms. Satellite monitoring. Commercial satellites photograph the playa weekly. Machine learning algorithms identify new trails and rock position changes. Social media tracking. Instagram and Twitter posts are monitored for sailing stone observations. Hashtags aggregate citizen observations. This democratization of observation means movements are unlikely to go undetected. Formal programs engage the public in sailing stone research. Adopt a Rock program. Individuals sponsor GPS tracking of specific rocks. They receive updates when their rock moves and contribute to equipment costs. Student research projects. Schools conduct sailing stone experiments in controlled conditions. Results contribute to understanding the mechanism. Photography projects. Artistic documentation is archived for scientific use. Time-lapse projects reveal subtle changes. Weather monitoring. Volunteers maintain weather stations near Death Valley. Data improves movement prediction. Trail mapping. Hiking groups document trail conditions and changes. Their observations extend scientific monitoring. These programs show science as participatory rather than exclusive. Virtual exploration technology enables virtual engagement with sailing stones. VR experiences. Virtual reality recreations let people experience racetrack playa without traveling. Time-lapse shows rocks moving at accelerated speeds. Online simulations. Interactive models let users experiment with different conditions. What wind speed moves which rocks? How does ice thickness affect movement? Live streaming. During potential movement conditions, cameras stream live. Thousands watch, hoping to witness movement. Digital archives. Historical documents, photos, and data are digitized and accessible. Anyone can explore 60 years of observations. Educational games. Games teach the sailing stone mechanism. Players must create correct conditions to move rocks and score points. Virtual engagement expands access while protecting the physical site. Scientists anticipate future revelations. Movement prediction. Machine learning might predict movement events days in advance. This would allow researchers to position themselves for observation. Mechanism refinements. Details of ice-rock coupling remain unclear. How exactly does ice grip rocks? What determines which rocks move? Historical reconstruction. New dating techniques might reveal movement history over centuries or millennia. This could show climate cycles. Microbial influence. Bacteria might affect mud properties or ice formation. Biological factors in movement remain unexplored. Subsurface dynamics. Ground-penetrating radar might reveal subsurface features affecting movement. Hidden topography could influence patterns. These potential discoveries show the story isn't finished. Protecting the sailing stones faces mounting challenges. Tourism pressure. Solved mysteries often attract more visitors than unsolved ones. Infrastructure struggles with increased traffic. Climate change. Altered conditions might end the phenomenon. Should we intervene to preserve it? Documentation balance. Research requires equipment installation, but this impacts wilderness character. How much modification is acceptable? Access equity. Remote location privileges those with resources to visit. How can the experience be shared equitably? Cultural preservation. Indigenous connections to the land must be respected alongside scientific and tourist interests. These challenges require balancing multiple values and stakeholders. Establishing century-long observation programs. Permanent installations, solar-powered, self-maintaining equipment could monitor for decades. Automated systems reduce human impact. Data continuity. Protocols ensure future researchers can interpret current data. Standardization enables long-term comparison. Funding models, endowments and trusts provide stable funding independent of political changes. Long-term research requires long-term support. Institutional memory. Universities and parks develop programs to maintain expertise across generations. Knowledge transfer becomes formalized. Global coordination. International collaboration compares sailing stones worldwide. Patterns might emerge from aggregate data. This long-term perspective extends beyond individual careers or even lifetimes. The sailing stones have entered mainstream culture. Movies and TV, documentaries feature the mystery prominently. Fiction uses sailing stones as plot devices, messages from aliens, portals to other dimensions, ancient markers. Literature, novels use sailing stones metaphorically, characters who move without apparent reason, relationships that leave trails. Poetry explores themes of patience and revelation. Music, composers create works inspired by the phenomenon. One symphony uses GPS data to generate melodies. Rock movement becomes musical movement. Video games, games feature sailing stone puzzles. Players must create correct conditions to progress. The mechanism becomes gameplay. Art installations, artists recreate sailing stones in galleries. Mechanical systems move rocks imperceptibly slowly. Viewers must return repeatedly to notice changes. This cultural penetration shows how scientific phenomena become cultural symbols. The sailing stones have become teaching tools. Scientific method. The 60-year investigation exemplifies hypothesis testing, revision, and breakthrough. Students learn science as process, not facts. Interdisciplinary thinking. Understanding requires geology, physics, chemistry, meteorology. Students see connections between fields, patience and persistence. The long solution time teaches that some problems require generations to solve. Quick answers aren't always possible. Observation skills. Detecting rock movement requires careful observation. Students learn to notice subtle changes. Mystery appreciation. Unsolved problems are presented positively. Students learn to be comfortable with not knowing. The sailing stones teach more than facts. They teach approaches to knowledge. Philosophers use sailing stones to explore concepts. Agency and causation. Do rocks have agency when they move? What constitutes action versus reaction? The phenomenon challenges simple causation models. Observation and reality. If rocks move when nobody watches, did movement occur? The phenomenon engages with observation paradoxes. Time and event. Is rock movement a single event or multiple events? How do we bound phenomena in time? The trails raise temporal questions. Knowledge and mystery. Can something be simultaneously known and mysterious? The solved yet wondrous phenomenon explores this tension. Nature and culture. How does explaining natural phenomena change their cultural meaning? The solution's impact examines this relationship. These philosophical explorations show the phenomenon's intellectual richness. Thousands have made the pilgrimage to Racetrack Playa. Life-changing encounters. Some describe seeing the trails as transformative. The physical evidence of impossible-seeming phenomena shifts worldviews. Spiritual experiences. The playa's isolation and mystery create contemplative states. Some report profound insights or emotional releases. Scientific awakening. Children seeing sailing stones often become interested in science. The phenomenon creates future researchers. Artistic inspiration. Artists find creative energy in the landscape and mystery. Works created after visits often reference movement and patience. Personal challenges. The difficult journey to reach the playa becomes meaningful. Overcoming obstacles to witness mystery creates lasting memories. These experiences show the phenomenon's impact beyond scientific understanding. Scientists have written personally about their sailing stone experiences. Richard Norris describes the moment of first witnessing movement. The ice began to crack with a sound like distant thunder. Then, impossibly, the rocks began to move, not dramatically, not quickly, but unmistakably. Decades of waiting resolved in minutes of observation. I found myself crying, partially from cold wind, mostly from joy. Paula Messina writes about solo research, camping alone at Racetrack Playa, surrounded by moving rocks and infinite stars. I felt simultaneously insignificant and central to something magnificent. The rocks were teachers in patience, persistence, and humility. Sharp's widow shared his final notes. Even dying, he wondered about the rocks. His last coherent words were about wind speeds and ice thickness. The sailing stones gave his life direction, literally and figuratively. These personal accounts humanize scientific research. People find personal meaning in sailing stones. Life journeys. The trails represent life paths, seemingly random but following hidden logic. People see their own journeys reflected. Patience rewards. Waiting for correct conditions resonates with personal experience. Success requires patience and preparedness. Hidden forces. Invisible influences moving heavy objects parallels life experiences of unseen forces creating change. Trail legacy. Rocks leave marks that outlast their movement. People consider what trails they're leaving. Transformation moments. Rare alignment. Creating movement mirrors life breakthrough moments when everything aligns. These metaphorical interpretations show how natural phenomena become personally meaningful. Despite the basic solution, mysteries persist. Initiation problem. What exactly starts a stationary rock moving? The initial breakaway requires overcoming maximum static friction. Ice must couple perfectly with rock surface. Selection mystery. Why do identical rocks in identical positions behave differently? Micro variations in ice contact. Tiny differences in mud conditions. Quantum randomness. Maximum limits. What's the largest rock that could move? Theoretical calculations suggest multi-ton boulders are possible, but none that large have been observed moving. Historical frequency. How often did rocks move in past centuries? Climate variations might have created very different movement patterns. Prediction possibility. Can we ever predict exactly which rocks will move when? Or is there fundamental randomness in the system? These questions keep scientists returning to Racetrack Playa. The sailing stones connect to other mysteries. Sailing stones on Mars, similar trails on Mars might have different causes. Understanding Earth's mechanism helps interpret Martian geology. Antarctic blood falls. Red water flowing from glaciers involves iron oxidation and bacterial action. Like sailing stones, it seemed impossible until explained. Morning glory clouds. Rare roll clouds in Australia form through specific atmospheric conditions. Like sailing stones, they require perfect alignment of factors. Earthquake lights. Luminous phenomena. Before earthquakes remain partially mysterious. Multiple mechanisms might contribute, like with early sailing stone theories. Ball lightning. Still not fully explained. Ball lightning might involve multiple mechanisms. The sailing stones show that mysterious phenomena can have simple explanations. These connections show sailing stones as part of a larger class of rare natural phenomena. With sailing stones explained, what becomes Death Valley's next mystery? The singing sand. Certain dunes emit musical tones when disturbed. The mechanism is partially understood, but not completely explained. The moving mud. In some plays, mud forms patterns that shift without obvious cause. Less dramatic than sailing stones, but equally puzzling. The racetrack's origin. Why is this play so perfectly flat? The geological processes creating such flatness remain partially mysterious. Life in extremity. How organisms survive Death Valley's conditions pushes biological understanding. Extremophiles here might reveal life's limits. Underground rivers. Hidden water flow beneath Death Valley remains partially mapped. Underground connections between basins are suspected but unproven. These ongoing mysteries show Death Valley as a continuous source of scientific puzzles. Our exploration of the sailing stones has taken us from initial mystery through decades of failed theories to eventual solution. We've seen how human patience and nature's patience finally align to reveal the secret. We've explored the science, the culture, the philosophy, and the personal meaning of moving rocks. The journey shows that natural mysteries are worth pursuing, even when they seem impossible to solve. The sailing stones required 60 years, dozens of scientists, evolving technology, and considerable luck to explain. Yet the explanation, once found, was elegantly simple: thin ice, light wind, and rare conditions aligning. The fact that thin sheets of ice, pushed by gentle wind, can move massive boulders remains extraordinary. Understanding the mechanism doesn't make it less remarkable. If anything, it makes it more so. The precise choreography required, the rarity of perfect conditions, the elegant physics of ice panels becoming sails for rocks. These details enhance rather than diminish our awe. Consider what must align. Rain must fall in one of Earth's driest places. Temperature must drop just enough to form ice, but not too much. Sun must break the ice into panels at just the right time. Wind must blow at just the right speed and direction. The probability of witnessing this is vanishingly small. The Norris cousins, waiting in freezing dawn to see rocks slide slowly across wet mud, witnessed something as rare as a solar eclipse, as precious as finding a perfect diamond. The sailing stone story shows how mysteries can unite diverse communities. Professional geologists worked alongside amateur photographers. Indigenous knowledge holders shared space with NASA scientists. Children wrote letters with theories while professors published papers. The rocks moved for no one and everyone equally. This democratic nature of mystery is precious in our specialized age. The sailing stones didn't require advanced degrees to wonder about. A child's question, "How do the rocks move?" was as valid as a scientist's. The final solution came not from elite institutions but from dedicated individuals using consumer technology. The mystery belonged to humanity, not to experts alone. Social media has transformed how we engage with natural mysteries. Today, a visitor to Racetrack Playa can instantly share observations with global audiences. Scientists monitor Instagram for citizen observations. YouTube videos explain the mechanism to millions. The sailing stones have become globally accessible even as the physical location remains remote. The sailing stones generate significant economic activity. Tourism revenue. Death Valley National Park sees over 1 million visitors annually, many drawn by the sailing stones. They contribute roughly $100 million to local economies through lodging, supplies, and services. Research funding. Grants for sailing stone research have totaled millions over decades. This funding supported not just rock studies but broader Death Valley science. Media production. Documentaries, books, articles about sailing stones generate revenue and employment. The mystery has been commercially productive. Educational materials, textbooks, museum exhibits, online courses featuring sailing stones create educational economy around the phenomenon. Adventure tourism. Specialized tours to Racetrack Playa, though limited by protection needs, command premium prices. Guides, equipment rental, and support services benefit. This economic dimension shows how natural mysteries translate into human livelihoods. The rocks that move for free generate very real monetary movement. As Earth's climate changes, the sailing stones face an uncertain future. Temperature trends. Death Valley is warming faster than global averages. Winter freezing events might become rarer. The temperature window for ice formation is narrowing. Precipitation changes. Climate models disagree on future rainfall. Some predict increased intensity, but decreased frequency. Others suggest total precipitation decline. Either change could affect rock movement. Wind pattern shifts. Changing temperature gradients alter wind patterns. The mountain valley winds crucial for rock movement might strengthen or shift direction. Playa chemistry. Different weather patterns will alter the playa's salt concentration and mud properties. The surface that enables sliding might fundamentally change. Ecosystem shifts. Climate change might bring new organisms to racetrack playa. Biological soil crusts could alter surface properties. Invasive plants might change water distribution. Scientists are establishing baselines now to detect future changes. The sailing stones might become climate change sentinels, their movement frequency recording planetary shifts. Future generations might study our documentation to understand climate impacts. Emerging technologies will revolutionize sailing stone research. AI pattern recognition. Machine learning algorithms might detect subtle patterns humans miss. Prediction of movement events could become possible. Quantum sensors. Ultra-sensitive quantum devices could detect minute ground movements, revealing previously unknown factors in rock sliding. Bioengineering. Modified organisms might be designed to report on playa conditions, acting as living sensors for movement prediction. Nano-tracking. Microscopic trackers could monitor individual sand grains, revealing how surfaces change during movement events. Climate modeling. Supercomputer simulations might predict long-term changes in movement patterns, helping preservation planning. Virtual reality archives. Future generations might experience historical movement events through VR recreations based on current data collection. These technologies promise deeper understanding even as the phenomenon itself might be changing. The sailing stones ultimately teach us about the nature of reality and our relationship with it. Reality is patient. Natural phenomena operate on their own timescales, indifferent to human urgency. We must adapt our expectations to nature's rhythm. Simplicity underlies complexity. The most mysterious phenomena often have simple explanations. Complexity emerges from simple rules applied repeatedly. Observation changes understanding. The act of watching, documenting, and studying transforms mysterious phenomena into understood processes. But understanding doesn't eliminate wonder. Mystery is temporary and eternal. Specific mysteries get solved, but mystery itself persists. Each answer reveals new questions. The sailing stones are explained, but Death Valley holds endless mysteries. We are part of the phenomenon. Humans studying sailing stones become part of the story. Our trails of investigation parallel the rock's trails across the playa. The sailing stones have inspired a rich literary tradition. Writers use them as metaphors for human experience. We too move through life, pushed by invisible forces, leaving trails that persist after we're gone. We too sometimes move in unexpected directions, sometimes travel parallel with others, sometimes journey alone. Poets find in the sailing stones perfect imagery for patience, persistence, and sudden breakthrough. The rocks waiting decades for perfect conditions mirror human experience of waiting for opportunity. The moment of movement after years of stillness captures life's transformative instance. Science fiction authors imagine sailing stones as markers left by ancient civilizations, navigation beacons for spacecraft, or evidence of parallel dimensions intersecting with ours. The solved mystery becomes launching point for new mysteries. Children's books use sailing stones to teach patience, observation, and scientific thinking. Anthropomorphized rocks become characters learning to wait, to move together, to leave their mark on the world. Artists continue finding inspiration in the sailing stones. Land artists create installations mimicking or responding to sailing stones. Some place rocks in galleries that move imperceptibly slowly over exhibition periods. Performance artists enact human versions of sailing stones, moving slowly across landscapes, leaving trails in sand or snow. Digital artists create algorithmic art based on rock movement patterns. GPS data becomes visual composition. Trail patterns generate music. Photographers continue documenting the playa's changing states. Time-lapse projects show the landscape's subtle evolution. Night photography captures star trails above rock trails. Filmmakers use sailing stones as narrative devices. Characters' lives parallel rock movements. Long stillness punctuated by sudden change. This artistic engagement shows how scientific phenomena become cultural touchstones. Teaching methods have evolved to incorporate sailing stones. Project-based learning. Students design experiments to test movement mechanisms. They build scaled models, test hypotheses, learn through failure. Plans exist for a Sailing Stones Interpretive Center. Virtual Playa. Full-scale virtual reality recreation allows visitors to experience racetrack playa without traveling there. Movement theater. Time-lapse films show rock movements at various speeds. Visitors can watch years compress into minutes. Interactive exhibits, hands-on demonstrations of ice rafting mechanism. Visitors can experiment with conditions creating movement. Research archive, complete documentation from 60 years of study, accessible to researchers and public. Climate change gallery, shows potential futures for sailing stones under different climate scenarios. Cultural collection, art, literature, and music inspired by sailing stones, showing cultural impact beyond science. This museum would preserve and share the sailing stone story for future generations. Accelerated. Quote, something deeply meditative about the sailing stones. They embody Wu Wei, effortless action. The rocks don't strive to move. They move when conditions align. Force isn't required, only patience and readiness. They demonstrate impermanence. Chirals that seem permanent fade. Rocks that seem immobile journey. Nothing remains unchanged. They teach non-attachment. Scientists who studied them for decades without seeing movement had to release attachment to witnessing the phenomenon. They show interconnection. Rock, ice, wind, sun, and mud must all interact perfectly. Nothing moves in isolation. They exemplify presence. The rocks exist fully in each moment, whether moving or still. They don't anticipate or remember, just be. This meditative quality draws spiritual seekers alongside scientists. Children have special relationship with sailing stones. They ask the best questions. Do the rocks want to move? Are they racing? Do they get lonely? These questions, while not scientific, capture emotional truth about our relationship with mystery. They create the best theories. Underground giants are bowling. The rocks are dancing when nobody watches. They're trying to escape the desert. These theories show imagination, unconstrained by education. They have the most patience. Children will watch a rock for hours, convinced it might move any second. They haven't learned that some things happen on timescales beyond human attention. They find the most meaning. For children, moving rocks prove the world is magical. The explanation doesn't diminish this magic, but confirms it. The world really does contain wonders. The sailing stones teach scientific humility. Observation limits. We can't observe everything. Some phenomena require multi-generational patience. We must accept partial knowledge. Theory revision. Even well-established theories need revision. The sailing stones required rethinking basic assumptions about ice, wind, and friction. Interdisciplinary need. No single field could solve this. Geology, meteorology, physics, and chemistry all contributed. Disciplinary boundaries hindered understanding. Technology dependence. We couldn't solve this without appropriate tools. How many current mysteries await future technology? Luck's role. The solution required being present during rare events. How much discovery depends on fortunate timing. This humility makes scientists more open to unexpected explanations. Even fully explained, wonder persists. The physical wonder of massive rocks moving across flat ground remains astonishing. Understanding the mechanism doesn't make it less remarkable. The temporal wonder of phenomena operating on decade scales remains humbling. In your dreams you might see them move, slowly, majestically, pushed by translucent sheets of ice across the temporary lake. You might hear the crack of breaking ice, feel the cold wind, witness the impossible made real through simple physics, or you might simply see them sitting still, waiting, patient as mountains, teaching through stillness rather than movement. Either way, you've been part of their story now. You know their secret. You understand their journey. You've joined the generations of humans who've wondered, studied, and finally understood how rocks sail across the desert. The sailing stones have shared their mystery with you. They've shown you that the world still holds wonders, that patience rewards the persistent, that simple explanations can underlie the most mysterious phenomena. The rocks will continue their journeys long after we're gone. Climate change might alter their patterns. Technology might reveal new details. Future generations might discover aspects we've missed, but the essence will remain. Massive stones moving across flat ground through the perfect alignment of natural forces. Trails carved in earth recording journeys we rarely witness. Mystery persisting even in explanation. The sailing stones remind us that we live in a world where impossible things happen regularly, where patient observation reveals nature's secrets, where simple mechanisms create profound mysteries, where understanding enhances rather than diminishes wonder. As you drift into sleep, carry with you the image of those patient rocks, waiting through years of stillness for perfect conditions. Remember that you too might be waiting for your moment of movement, when all conditions align and impossible journeys become possible. The sailing stones have moved across racetrack playa for millennia. They'll continue long after we're gone. But for this moment, in this time, we've witnessed their secret, understood their mechanism, and joined the eternal procession of humans seeking to understand the mysteries around us. Sleep well, dream of sailing stones, and remember, in a world where rocks can sail across the desert when no one's watching, anything is possible. The impossible just requires the right conditions, patience to wait for them, and presence to recognize when they arrive. The rocks continue their patient wait. The mystery continues even in solution. The wonder continues even in understanding. And somewhere in Death Valley tonight, under stars brilliant in the clear desert air, rocks sit on the playa, waiting for ice and wind and sun to align once more, ready to sail across the desert floor, leaving trails that will puzzle and inspire future generations, just as they've puzzled and inspired us. The journey continues. The rocks sail on. The mystery persists in new forms. Welcome to a world where stones sail across deserts. Welcome to a reality stranger, and more wonderful than fiction. Welcome to the continuing mystery of the sailing stones of Death Valley.